Hi everyone, it's time for another video. Basically what I got this from eBay. It is, as you can see here, video signal distributor. So you got your RGB coming in here, and then you get your RGB distributed on these. These are usually used in airports or hotel lobbies and stuff like that to give one signal in and then drive many different monitors or screens or whatnot. I thought it would be a good idea to use this to, I thought I don't have any frequency reference in my lab. I thought it would be a nice, good idea to have something that generates a 10 megahertz signal to, to give out to for other stuff. Or maybe when I got my function gen, I can just put a signal in and then get different signals out for different types of work and stuff I do. So the problem with this is I haven't tested this if it works or not. So you got a signal, power coming in from the front. We just put the power in and see what happens. Okay, as you can see here, this LED is flashing. I don't know if it shows on the. Yeah, you can see this shouldn't be flashing. It should. I think it should be just a normal on. Changing any of this? Nope, it doesn't change anything. So what we're gonna do, I'm gonna put a signal in and then see if I can get a signal out or something. So I've just put my signal generator on, and then just quickly test it. See if I get anything. So if I got the input here, down here. And then we get the output going to the scope. I don't know if this marked as faulty or not. I think it's just marked as not tested or anything like something like that. Okay, I'm feeding signal in and I'm not getting anything out on the scope. So I've got the R into the R, and first one is not giving anything out. Second one is not giving anything out. Okay, I've got the highest. Let's just bring the signal down, just in case, maybe. Okay, so I'm feeding like 6 megahertz and it's not doing anything. I'm not getting anything out on the outputs. Okay, let's just go to a different output. Nope, I'm not getting anything there. I'm curious about this LED flashing. What I'm getting at the moment on the scope is a kind of on and off, like a square wave, but very faint, but it is corresponding with this flash. So every time it's flashing I get a signal there. So probably there's some sort of issue with maybe a power supply or something like that. So okay, safe to say that it's not working. So let's just not have it on anymore, destroying equipment. Let me just turn the signal gen off. Let's just take this apart and see what's what. I already opened the screws, took the screws out, just to make life easier for us. That's what we've got here. That shows on the camera. Yep, so we got our switch mode power supply going into this, and I think this comes off. Yep. Alright, let's just take the LED out. We don't need the LED at the moment. So what we got here, we got a switch mode power supply, and I believe whatever voltage is feeding here, and this is the back of it. So we can see we got our op amps for obviously amplifying the signal as a buffer or whatever it is, and this being display for video, it is terminated at the output is 75 ohms, which is not good for us because we want 50 ohms. Obviously all the electronic equipments, it is at 50 ohms, so the input impedance. So what we need to do is we need to obviously change something around here to change the 75 ohm to 50 ohm. So as you can see here are these blue resistors. If I can just get this out, Then we can get rid of this. Oh, we got that. Don't worry. Ah, yes. Must be a really hard one to open up. Like always, there's always a screw that plays around. Okay, so come out. There we are. So let's get rid of that as well. Let me just bring this forward for you. There we go. So you can see the resistors. I'll just go here. You can see these resistors, they're all 75 ohms. We got some over here, we got some over here, and we got some over here. So what I need to do, I need to change these to 50 ohm resistors. I believe I might have some 50 ohm resistors that I took off some test gears time ago. There might be actually the same kind of resistors that they use in here. As you can see here, these are kind of a precision resistors. You can tell by the color of the surface mount resistor, these are blue, so they'll probably be 1% or maybe better than that. So I'll need to change that. And we can see the op amps. There we go, we got a, I believe it's a Linear Tech DC-DC converter. But what we got here, over there, is you can see the resistors got some form of reaction to whatever must have either gone on them or to the air or moisture or something. So the lead, the solder is reacted with something, and you got oxidization over there. So just got to check to see everything's working okay there. Over here, a bit of a budge, as you can see there. Everything else looks alright. There we are. Can maybe read the, there we go, CL409 op amps. There we go, 75 Rs, the resistors. And we got two HCO4s. Okay, so let's just take the front out as well. I've already opened this, obviously, because it was going to take time to go through all the pins of dismantling that. So what we got here. So the camera is glaring. Obviously you would have had more of the BNC plugs there, but they've just used the resistors to just terminate those. And we've got the same over here, so you would have had 4 and 4 more. So at the moment this is, you got the input RGB, and then you got 8 output, 2 of sets of 8 output. But then if you had these, you would have had 2 sets of 12 outputs. So basically what you do, you feed your RGB here. I don't know what that signal is, it might be sync or something. Let me just see. What's the last one? It doesn't say what the last one is. It doesn't have, I can see here, it just says RGB. It doesn't say what the last one is. Yeah, it's probably sync because it's got sync gain over there, so this last one must be sync. So what we got here, we got RGB going here, and then you get RGB out, and then you got your sync again on the other side, RGB out. So you got RGB here, and then 2 sets of RGBs out that side and 2 sets of that side. I don't need to, I do have spare of these around, but I'm not going to be bothered to take these out and put these on, because even though that the front panel has place for them, I just can't be bothered. I think that's more than enough for what I need. So what we need to do is find out what the problem is, and this is the power supply bit. So what we got here, we got a DC-DC converter over there generating some sort of something. So what we got here, I don't know if that's visible in the camera. No, the camera doesn't like to zoom. There we go. So we got 7805 there and 7905. So clearly you got the plus and minus for the op amps. And inductors, couple of inductors for the switch mode power supply. And oh, what do we have here? Okay, something's going on over there, as you can see here. There we got something oxidizing, and we got a lot of crap on the PCB. So that doesn't look healthy. I wonder if that capacitor has seen better days. So see from this side, you can see better. There we go. Okay. I think what happened is the PCB, the tracks might have been compromised, might have been something happened, because I can see a bit of copper over there. So what I'm going to do is I'm going to take this capacitor out and find out exactly what's going on. Obviously there's something wrong with this power supply, that's why I think it's flashing. So let's just warm up the soldering iron and see if we can get rid of the capacitor. We go here, there we are, and we just zoom in. There we go. So what we need to do is we need to get this capacitor out. So it would have been these two tracks over there. Okay, so what we need, get this out. Okay, seem to be stuck there. Okay, we got it out. Okay, that doesn't look healthy to me, because I think capacitor just took out. Yep. This capacitor's seen better days. There we go. There you can see, I think capacitor has discharged it's inside out. Clearly there is a, you can see there's residue there. It is IC brand, never heard of them before. We get rid of that, and if we just come here, let me just show you what the problem is. And we can see here, yep, definitely something's happened here. If I can get this, you can see the copper there, everything just lifting off. Look at that. Oh my god, that is not a good sign. Let's just get rid of everything. So we've got the copper there. I wonder if anything is oops, sorry, mind the camera, talking to myself. There we are. Wonder if this hole over here has got the tracks at the back, because this one here, I wonder if they're both at the back. Let's see at the back. Okay, so what we got here, we got this one going to some track underneath this connector here, so we're safe with that track. but this one, I'm not sure where this one goes. Let me just turn it around. So this one, I'm not sure where it goes. It might be connected to the middle ground. There might be a ground in the middle, or there might be a ground out somewhere else, or it might be positive in the middle. Something, it might be connected to something. So what I'm going to do, I'm going to just use a continuity test and see what that connects to, just to make sure that the track for this pin of the capacitor hasn't hasn't got damaged, and that is connected to something. So what we're going to do is we're going to just put it down, and here, and I'm going to get my flux meter. Yep, we're on the wrong track. We got here. That's fine. So let's see what that's connected to. We just quickly get it ground. Okay, as you can see here, I don't know if obviously not showing in the camera. So what we got here, I got my plug here, so I'm connecting this to just one of the grounds, and I'm using just this little pin to connect to this. Okay, as you can hear, there we go. So that's connected. So that is the ground, and this one, let's see what it is. Okay, so that's a good sign. So that is connected to something. So basically, that is, I think, the positive that's coming into the circuitry here, and obviously the other one was the ground, which is connected to the ground. Here, which is connected to the ground of the power supply. So what we got to do is, I don't know if that shows. Yep, here we are. So we got ground over there, and we got the positive, which is coming from here. I do know that this middle pin is the negative because it's connected to all the big plain ground on the actual PCB. So the middle is the ground that comes in, and this is the positive that comes in. So this must be connected to something between these two. So basically it is filtering the line that's coming into the DC-DC converter here that we have. Let me just double check to see if these capacitors are alright. This one looks kind of funky as well. I need to just zoom out a bit. Okay, so we got here, this one might be damaged as well. If the camera tries to zoom in, there we are. As you can see here, we got some oxidization at the bottom there. I don't know if that shows. There we are. So what I'll do, I might take this out as well. The rest seem to be alright. Now what I need to do is I need to actually connect the power supply that we have here, this power supply, and make sure that the output of the power supply is okay. I mean, these are all the caps for the power supply we got here, and they seem to be all alright. They're kind of like Nichicon branded. Sorry, yeah, Nippon Chemical, sorry, not Nichicon, yeah. So they got that kind of brand, although it doesn't say on it, but it's got the little mark on it there. So they don't see any bulging or any leakage or anything like that. So the power supply might be fine. So I'm not going to test the power supply. What I'm going to do is I'm going to just quickly solder this. There we are. Solder this capacitor, which was 100 microfarad, 25 volt. I believe I have similar to that. There we go. So we're gonna go use the same kind of thing. There we go. Same kind of brand as the actual power supply. So this time we're gonna use a 35 volt instead of a 25 that's out there. And it's gonna go inside like so. There we go. So let's just quickly solder this in. Let me get my solder. That's gone through. Solder this as well. That's gone through as well. What we're going to do, we're just going to cut these out. There we are. And cut that one out as well. So that's done now. As you can see here. Let's quickly power this up. See if we get anything. Okay. Nope. Let's go this way. And then we got here. We got the line connector there. Okay, no, we're still getting the same kind of flash that we were getting before. As you can see here. Let's quickly check the voltages. See what kind of a voltage we get. So let's just put that aside. Okay. So what I'm going to do, I'm going to just connect this to the ground. I can hear a clicking noise. So that's obviously not healthy. Okay, so we're not getting what we should be getting. Okay, let's see. As you can see here, if I go to AC, so we're not getting anything at the moment. So obviously there's something wrong with the power supply board on this. These seem to be cool, so I don't think they're getting the right voltage in them. Okay, well, the DC-DC converter is very hot, extremely hot actually, and yeah, obviously there's something going on with the DC-DC converter. So there's something going on with the power in this. So what we need to do is, I need to find, let's see, this video is going to get too long if I'm going to go through and fixing the whole thing right now. So what I'm going to do, I'm going to make this into a two-part video. So right now we found the problem. The problem is with this section of the board. So obviously the power of the board. So what we got here, these op amps will require obviously positive and negative. So what they're having here, what I can see from these is that they go plus and minus 5 volt. They're feeding into this. So the plus and minus 5 volt is going into all the circuitry and stuff. So what I might do is I don't think I do have this part of linear tech. I might do actually. I'll salvage some parts and stuff from test gears and stuff. So I might just swap this if I have any. If the problem is the actual chip. If the chip wasn't at fault the problem, then what I might do, I might just change this whole thing. Change this whole power supply that I have here. I might put a linear power supply inside this. I might put a linear power supply inside this because I've got a lot of transformers and stuff lying around. So that's one thing I might do, because what I want to do is, as I said, I want to have signals coming out of this, 10 megahertz signals coming out of this. So I need to be using this, which is oven. Basically, it's got a big oven inside, and it's a crystal oscillator. So it's oven crystal oscillator 10 megahertz reference, and this is very stable. I could have bought those things that you see people buying on the net, rubidium frequency standard, but right now they're very, very expensive on eBay. You pick one for like about 100 and more than £150, which I don't think is worth, because I don't need that kind of stability. This is fine for the works that I want to do. So this requires a 12 volt for the oven, and within about 5 minutes this settles to its you know, to its optimum. So at that 5 minutes when you first turn it on to the time that is settled, it's going to require about 600 to 700 milliamp of power just on the 12 volt for the oven, and after that obviously it just calms down and then just maintains the, you know, the temperature of the oven. So it's not going to require that much, but the first 5 minutes it requires about 600 to 700 milliamp at 12 volt. So the power supply that I'm going to be using requires to have a good 12 volt output and then a good plus or minus 5 volt output. So what I've got here, this is something I salvaged before. There we go here. So what we got plus or minus 12 volt and then a plus 5 volt. So what I can do is, this is the 12 volt, which is 2 amp, which is perfectly okay to power everything, and this at the same time. So what I might do is, I might just feed the plus or minus 12 volt here to these voltage regulators that I've got here, and just bypass the switch mode power supply altogether, and just feed the plus or minus into these and get my plus or minus 5 volt for everything else here. And then I will have the plus 12 volt to feed into this to get my my 10 megahertz reference out, which I'm going to be feeding into, you know, one of these, or maybe 2 of these, or maybe all 3 of them. I don't know. I'm just going to check first, see what kind of a thing I'm going to use this for, and then it should be working fine. And as you can see here, I do have standoffs for I think different kind of power supplies. So I might just, I might just fix this on top instead of using this little tiny one here. There might be something wrong with this, so I'm going to be using this beefier one. Anyway, that's for a second part of the video. Thanks for watching. As always, if you like the video, please give it a thumbs up, and until next video, goodbye.